Unit 3, mechanical rates. What we're going to be looking at today is linear rates. And remember what linear means. When you see that word there, you see the word line. That means that everything is in a straight line. Okay? If you're traveling a distance, then you're measuring the time along that same distance, so it's in the same line. The velocity that you calculate is in the same line. Okay, so that's one of the things that you need to make sure that you do understand, is that when you're talking about mechanical rates, you've got linear, and later on we'll do angular, or sometimes people like to call it circular or rotational. All right, but this one is talking about linear, so we're talking about everything being in the same line or same plane. All right, well, there's two kinds of quantities when you start talking about rates. You've got scalar quantities, which means magnitude only, which is the number value. All right, for example, you measure 6 inches. It doesn't matter what direction you measure the 6 inches, you measure 6 inches. All right, the example that I just gave there was 55 miles per hour in your PowerPoint here. Vector quantities are magnitude and direction. Direction takes on a major role here. Okay, as you're gonna start to see. For example, we again have 35 miles per hour by itself. It's a scalar quantity, and they call it speed. Soon as you put a direction on it, it becomes a vector quantity. And that may not seem like to be a real big deal right now, but when you start to do problems and you are combining different velocities, all right, and so forth, it becomes a big deal. All right, this is one that you have been familiar with since elementary school, is calculating speed. You calculate speed by taking the distance traveled and dividing it by time. You didn't care what the direction was. All right, it could have been, back and forth. All right, it's still going to be your total distance over your total time. So that's speed. Doesn't have a direction. All right, here's just to make sure that you're up on things. Here you have a car travels 35 miles in 40 minutes. What is the average speed? Okay, well, 35 miles is going to be your distance. 40 minutes, that's going to be your time. So your average speed is going to be distance divided by time, v equals d over t. Now you have to be careful because in some textbooks they do use different symbols. Here we're going with the most simplest. D for distance, t for time. Alright, and notice v here is for speed. In many textbooks, v is speed and it's also velocity. And notice it says average. Alright, that's something to remember too, because later on we're going to introduce the fact that you've got different type of velocities and speeds. You have average, you have final, and you have initial. Now the final and initial may not make any sense right now, so don't worry about that until we get there, but right now this is average. That means your stops and starts and all kinds of stuff, so it is just an average speed. Okay, take your 35 miles divided by 40 minutes and you get 0.88 miles per minute. So that would be your average speed. Now, if you wanted to convert that and say, well, I don't know what miles per minute means. I only know miles per hour. Well, what you do is you take your answer, your 0.88 miles per minute, and this here, the 60 minutes over 1 hour, okay, what this is going to do for you is it's going to convert. Now, some people are always like, well, do I multiply or do I divide, by 60? What is it? This tells you every time. All right, you want to get rid of minutes and you want to replace it with hours. So minutes has to go on top. And how many minutes do you have in an hour? Well, you have 60 minutes in 1 hour. So what happens is minutes is going to cancel out. You're going to take the 0.88, all right, miles, and multiply that by 60 and divide it by 1 hour, and you get 53 miles per hour. Okay, that easy. Okay, now when we talk about velocity? All right, still going to be v, But this time, instead of distance, we have this big long word. It's called displacement. You may have heard displacement before if in some of your other science classes when they talked about water in a graduated cylinder and how much the water changes in levels. They'll call that displacement. Well, that's pretty much you're looking at a change in something. All right, so that's displacement, and it's over time. But you got to take direction into account, which is what we're going to talk about here. All right, there's a little rhyme I came up with many years ago to try and help students understand displacement versus distance. And this is basically how it goes. From where you start to where you end, it does not matter where you've been. Okay? So what you're looking at is where you started to where you ended. It didn't matter where all your travels took you otherwise. And here I have like a crazy crazy path. Here, this is where you started and you went all the way around and up here and down and around and all the way around crazy like this. Ooh, and then here's where you stopped. Alright, now if you were to do distance, you would have to add up all that stuff. Okay? But when you're talking about displacement, you were talking from here to here. Okay? That's where you started. This is where you ended. Alright? From where you start to where you end, it does not matter where you've been. Alright, so it's just this line right here. So that would be your displacement. You would just actually measure from here to here. Makes it a lot easier, doesn't it? Yeah, so don't write off learning something new here with displacement. A lot of times it can make things a lot easier. Okay, let's take a look at a problem. Alright, in this problem, you probably saw these, and sometimes they would put them on standardized tests and things like that. And they'd say, okay, a car is traveling east 5 miles for 7 minutes and then turns west and travels 35 miles for 23 minutes. What is the car's velocity? Okay, so basically what we're going to see, there you go. We're going to take a look at what's going on here. Alright, so we have this car, let's say, oh, I'm sorry, they went this way, started right here. 5 miles for 7 minutes, and then turned around, and then they went 35 miles in 23 minutes, alright, in that direction. Okay, now how do you figure that out? Alright, remember what we said before about where you start to where you end. Okay, so what we would do is we'd say, okay, well, how far is it from here? Go on a straight line here to here. So what you're going to do is you're going to subtract 35 and 5. So from here to here is 30 miles. Now the time is never subtracted because you can't have a negative time. Alright, we are going to have 7 plus 23, so that gives us 30. So we are going to have 30 miles because it's from here to here. That's 30 miles. Alright, our total time is going to be 7 plus 23. That gives you 30 minutes. Okay, and so that gives us 1 mile per minute. And if we wanted to change that to miles per hour, we're going to multiply that by 60 minutes over 1 hour. Minutes cancel out, and you get 60 miles per hour. Then what about this W? Where does this come from? Well, we said that they were traveling east in this direction, and then you were traveling west in this direction. There's two ways to look at it. Your magnitude is going to rule what's going on here. So you can say, well, the larger magnitude here is 35 miles and it's west, so it's going to be west. Another way of looking at it is if you stand right where you started, all right, and you turn to face the direction that you ended, which is over here. What direction are you facing? You'd be facing west. All right, that helps you in more complicated problems. All right, if you had a lot of vectors that you had to evaluate, that would help you in that sense. Alright, so you just learned how to do average velocity. And again, remember, average velocity is just that. You might have had, you might have been traveling different velocities all along this route, but your average ended up to be 60 miles per hour. Okay, let's take a look at some variables. Speed is v, distance is d, t is time. We saw that in our previous problems. In English, you could say, okay, miles per hour for your velocity, miles per minute. Okay, so then that would mean that your d would have to be in miles and your time would have to be in hours. Either that or you have to convert it. Alright, now in SI, you have kph. If you're driving, alright, and you look on your dash, you should have miles per hour and you should also have kilometers per hour. Okay, kph. Your distance would be in kilometers and your time would be in hours. Alright, so that would be the variables and the units that you'd be using. These are very important. I can't stress enough how important it is that you pay attention to units. It made a real big difference for me when I started to understand the importance of them, and they can tell you an awful lot. Okay, what about acceleration? Now I have pictures here of rides that you'd see at an amusement park. Why are amusement parks so, people want to go? Why do so many people attend them? Why do we want to ride roller coasters? Because of the acceleration. That's what gives you that adrenaline rush. That's why you want to ride them. That's why you want that better roller coaster, that faster roller coaster. Why you want those turns and those loops. That's why. All right. People love that. Okay, but it's what you're really feeling is actually acceleration, or in some cases deceleration, which means you're slowing down. Okay, well, again, we're talking about linear acceleration. We're talking about it being in a straight line. Now, when we talk about acceleration, we have to talk about changes in velocity. All right, again, that's what you're feeling. You're feeling a change. You're going faster. You're going slower. All right. So you're going to start off with the final velocity. Now what that means basically is you're looking at a period of time. It might be very short, but a period of time nonetheless. And the final velocity is the last velocity. And your initial velocity is your first velocity. And you are going to subtract those. Alright, so you're going to get a change in velocity. And then you're going to divide it by time. And that is going to give you your acceleration. Now, the same thing is true if you're slowing down. All right, that roller coaster is coming to a sudden stop at the end. All right, and you can feel those forces on your body. All right, the same thing is true, but the difference is going to be when you calculate your acceleration, you are going to get a negative number. You might say, oh, how can you have a negative number? I'm moving. It really just shows you direction, in this case, that you are slowing down. Okay, what about variables? For acceleration, linear acceleration, it's going to be a small a. Your final velocity is a v, and the f is usually written as a subscript, so it's a little smaller. I didn't write it like that here so that you can see it well. And then you have vi, which is your initial velocity, and t is still time. In the English, all right, if you were going to stick with miles per hour, all right, as your velocities, and they have to be the same, by the way. You can't have one that's miles per minute and one miles per hour, because otherwise you can't subtract them. You have to remember, go back to your algebra. It's kind of like if you have 2b and 4c, you can't subtract them because they are different. That's the same thing that's true with units. They have to be the same. So they both have to be in miles per hour, and your time, you'd want it to be in hours. You want to match whatever your time unit is here. Okay? Because otherwise you're going to get a funky number. Alright, some strange units. So anyway, what happens? Mile per hour divided by hours is going to give you miles per hour squared. Now, what about if it is in the SI? It's going to be kph squared, kph divided by hours. And then what do we have a problem here? We have 5 miles per hour, accelerates to 35 miles per hour in 0.1 hours. What's the acceleration? Well, it's going to be final minus initial divided by time. And you're going to subtract 35 minus 5 divided by 0.4 or 0.1 hours.